Jó. Disconnected. Ja, várjál. Jó lenne internet is hozzá. Persze, igen. Mennyi idő alatt kapcsolunk? Ilyenkor rá tudok nyomni, amikor egyből rá dugtam? Kikapcsolom és újra beindítom. Talán jobb lesz. Igen. A videó az megy.
Most valamit kérdeznek a páronktól.
Jó, még itt nem állt fel. Hívnak? Jó, oké.
Nem. Nem
Elindult, élőben van. Elindult.
So thank you everyone for coming to today's presentation. My name is Attila from Gamax, and I am here with my colleague Lajos Varga, Applications Engineer of Gamax, and Giuseppe Ridino from Networks. And today's topic is going to be computer vision, object detection. We're going to touch the topic of robotics application and automated driving system as well. And actually, Lajos is going to start the presentation with some information about TH. Basically, it is the academic license for Matlab and Simulink. So I'm just giving the word to Lajos. Thank you.
Thank you very much, Attila. And so what I'm going to do is just a couple of minutes, a very brief introduction of why we are here and what this license is that you have at your university. So my agenda is very brief, so let's dive into the deep waters of it. So what is a total academic headcount? What is that Matlab license? Usually we have tap on the water, we have electricity at the mains plug, and now Matlab is part of the university infrastructure as such. Matlab is available for all members of the faculty and all students to be used on computers here at the university, also to be used on personal computers of yours, be it a desktop or a laptop, and feel free to use the software for as many things you can. To download, the only thing you need to remember is that link over there, which is io.uni-obudai.hu/matlab. So you go over there, you will see a detailed explanation of how to get the software, how to download, how to install and activate, and then you're going to be ready to go. So that's the idea of the total academic headcount license, Matlab as an infrastructure. What you have covered is the base Matlab and Simulink and 48 additional toolboxes which give you all kinds of capabilities from signal processing all the way through robotics and so on, you name it, all kinds of applications. What you will see today from Giuseppe is more into image processing and robotics, but I think all of us who are here will find at least a couple of toolboxes relevant to his or her work. And one more thing I want to highlight is the Matlab Online. If you go to matlab.mathworks.com, you will have a browser-based Matlab ready to go. You don't need to install, it's available. After you have made a Mathworks account with your university email address, you can log in and then you can access this online Matlab tool, which is, I think, quite useful for homeworks and all kinds of light processing things. Also, we have additional resources for you, be it a student or an educator. Feel free to go to mathworks.com/academia, where you will see all kinds of resources on how to get started with Matlab if you were a student, and also how to teach with Matlab if you are an educator. If you are new to Matlab, what I would like to suggest for you to do is go to the Matlab Academy, where you will see a very short, brief ramp-up, which will get you started very quickly with the Matlab environment and language. And another thing which is quite nice is the Matlab mobile platform, because Matlab is available for Android and iOS, and I'll try to just show it to you. So this is how Matlab mobile looks like, and you can have all kinds of sensors activated on your mobile phone, like the GPS coordinates, and you can have these sensors deliver data to your desktop Matlab, and only your imagination is the limit on what you can do with this Matlab mobile. So I would encourage all of you to try it if you haven't already. And with this one you can also control your Matlab instance on your computer. A couple of new features in our latest release. If you are into deep learning, machine learning and data analytics, there are many new capabilities which has come up. if you are into automated driving systems, which is driver assist and self-driving cars, we have a new toolbox covering that. We also have the powertrain block set to model electric and hybrid powertrains. And my favorite of all is the new 5G library. If you are into any wireless research, the 5G is the new thing which is going to come in the next couple of years. So you can extend your research with these. If you happen to have any questions, feel free to go to our website where you can also contact us. And with that, I thank you all for your attention and I hand over to Giuseppe for his presentation.
Thank you. Thank you. Let me try it again. Okay. Let's see if this is working. The battery is dying, but should work. Okay, so first of all, thank you for joining this event. I'm very happy to be here. This is not the first time that I'm facing students and teachers at the university. I used to do this in Italy. I've been presenting in various universities, Polytechnic School, Roma University. I'm facing quite often hundreds of people, so this is like being with friends for me. And yeah, let me quickly introduce myself. So I joined Matlab 3 years ago. I'm a senior application engineer in Matlab. Prior to joining Matlab, I was working mainly as a consultant for various companies. And yeah, all my career was about simulations. So basically with math and simulating since last century. And these are some universities where I was studying. So the Polytechnic School of Torino, I graduated many years ago, already 20 years ago. Then has study experience at UPC in Barcelona, Spain, and the Custom in Germany. My working experience before joining Matlab was mainly in the automotive industry, so Fiat, FCA today. And these companies maybe are new to you, but these are, they don't exist anymore, they merged all together, and now is Leonardo company, which is an Italian public company working in aerospace and defense. It's a huge company with 25 sites in Italy, also offices in the US and the UK, and also in France. So yeah, in Matlab, I'm mainly working these topics here. You see, image processing, signal processing, communication system, HDL code generation. These are the main ones. So I have also some minor topics. And what we are going to see today, and this is an agenda that you probably know because you saw in the invitation. We will try, but I will try to cover computer vision topics with Matlab, mainly about object detection and recognition, and then I will move toward robotics application, and finally I will try to provide you with a sort of quick introduction and insight of the automotive industry, where autonomous systems are hot topic today. Okay. So if you have questions, don't be shy. Just raise your hands. Do the question. I will try to answer. If I can't answer, we will write down your question and we will come back later with some emails or some way. Okay? So don't worry. Okay. So just let me show some example of autonomous things. So autonomous systems, generally speaking. So we can find autonomous system in the medical, in safety and secure, consumer, agriculture, a lot. Driving, of course. And most recently, have you seen the Amazon news about the automatic delivery with drones? That's amazing. What are autonomous systems? What's behind an autonomous system? Is it easy? Is it difficult? How many things do we have to know in order to design an autonomous system? Well, it happens that it's difficult to have an autonomous system working properly. This one here is an attempt to have an autonomous car many years ago. It's not behaving very well. Yeah, absolutely, no way. That's wrong. And this is another one, so it's a humanoid. It's difficult. Why is it so difficult? It looks easy. Come on, open the door, get in. No way. Come on, just walk. Yeah, but you know the floor is a mess. Yeah, no way, no way. This is suicide, and this is not working at all. Okay, all these things is very problematic. Just one question, just to understand who is in front of me. How many of you are studying electric engineer? So a good portion of that one. How many are studying, for example, communications systems? If there is communication engineering studies here, I don't know. The other people, so not the electric engineers, what they are doing? Physics, mathematics, mathematics, control systems. You know, all these studies are inside those systems. You have electronic system, you have control system, you have image processing, you have HDL perhaps with FPGA, you have biologic concepts inside this, because something working is something biologically conceptual. It's not that easy. This is, I think it's only in the last few years that we have those humanoids in Japan that can run very easily. But we took 20 years to develop these kind of things. Okay, so this is the problem. Because we have to deal with control, with sensor. We have to deal with sensor fusion and perception. So the machine, to be autonomous, should understand what's around the scenario, should understand that there is an obstacle here, should not hit the obstacle, should avoid the obstacle, or perhaps this is not an obstacle, but this is the door I have to open. Then planning and logic. So an autonomous system should be able to autonomously understand the decision they have to take autonomously. There's no one saying, you have to go on the right. No, just go on the left. It must be fully autonomous. Otherwise, it's not an autonomous system. And then there is communication and coordination, control. So there's lots of things. Control system, communication system, logic, informatics, there is perception, there is sense or sensor. It's very complicated, very complex technologies. But they are all needed to have an autonomous system. You can't have an autonomous system without, I don't like sense, so without sense. I don't like planning, no. My autonomous system will plan nothing. That's not an autonomous system. So, since I'm Matlab, I will show you how you can do all these things with Matlab and Simon. So one question, who is already using Matlab or Simon or both of these tools? Okay, you are my colleague, you don't count. Okay, that's good. Good portion. Okay, really happy. Okay, this is tricky. Maybe I can break the ice a little bit. Which is the latest release of Matlab and OSimon? Has a name. The latest release is called, come on, HAR 2017. The guy was the first one. Very good. Congratulations. Yeah, HAR 2017. Hey, why is this so important? Because this is the release that you have in your university. So you have a TH, you have access to the 2017A release. But if you want to use also something older, yeah, you can. Why? I don't know. You can do, by the way, something. You can use also something older, but there's no need. So why is it so important? Because at MathWorks, we have a release cycle of 2 releases per year. Usually the 17A, so the A is March, April, usually. And then we have a B release at the end of the year, every 6 months. The B is not better than A, the A is not better than B, it's just 2 different releases, okay? And this is important because we keep on changing the tools, updating the tools, providing new features, new capabilities, fixing bugs. fixing bugs, fixing more bugs. Okay, so if you find a bug, just tell us there is a bug so we can try and fix it. And yeah, this is what you can do. You have everything in your release. You have control system toolbox that help you to design a control system. Then you have Simscape toolboxes. They are modern ones. Simscape is a language which is integrated with Simulink and allows you to design and model physical systems. Is someone using Simscape tools? Do you have any? Oh, one guy. Okay, you're the winner. So, what are you using Simscape for? Can you tell me one example? So I invite the people over there to answer, so I don't have to climb every time. So what do you use your Simscape for? Just an example. If you don't use, just give me back again. Okay, so electronic systems.
Yes.
Okay, so actually Simscape is a nice language. You can simulate, create and design all sorts of physical system like mechanical system, hydraulic system, electric system, electronic system. There are many things. The difference with standard Simulink is that in Simulink you are designing a system, and a system has no, when you connect the blocks, there is no topography in the blocks, just a standard systematic design. In a Simscape environment, when you derive a line, you are adding an equation at that point that say that something goes here is divided in two, which is different. So you are providing an equation of the topography that you are adding, like PSPICE, for example. Just maybe you know PSPICE for electronic systems, okay? And then there is also this piece here, Simulink real time. Why is this so important? Because you are designing your control system, you want to control a device, and a plant could be, let me say an example, a gas turbine. You don't have the gas turbine over there because it's huge, so you have to test your control somehow. So here you can part in, this is an industrial PC basically. You can part inside here a model of the plant of your gas turbine, for example, and you can plug the control and see if it's working. This is basically connected to your Simulink model, but the control that you develop here is ignoring at all that it's talking to something fake. And you see if it's working, okay? Then, let me go a little bit faster. For the sense, so hardware support packages. We have lots of hardware support packages. They are free, so free, I mean free. You download, install, and it works. And you are able to connect to hardware. Which kind of hardware? A low-cost hardware, for example, Arduino, Raspberry Pi, BeagleBone, up to the top hardware from, let me say an example, Philips medical devices. Okay, so from the €10 Arduino board to the highest end board from Siemens. And then you have also tools to acquire sense of data in Matlab. Then we have also the perception things. So computer vision is one of these, and we will go a little bit deeper in this, because I think this is one of the most used perception methods to collect perception of the environment. Is this something that you should very well know, because it's largely used in the industry, in the automotive industry, for example, or industry automation as well, when they have to detect pieces, mechanical pieces, for example, they classify the objects in this way. Then we have phased array that is able to perform modeling of radars, generically speaking, radars. And then statistic and machine learning that you can use together with computer vision for classification. Then planning. State flow. Do you know state flow? Who knows state flow? Who knows step flow? 1, 2, okay, just a couple of them. So step flow is an environment inside Simulink that allows you to design logic. So finished state machine, for example. And then we have the robotics instant toolbox. We will talk a little bit about this later. And then how to connect all the things. So we have communication toolbox to do communication systems. We have the Boolean system toolbox. And then we have also the robotic system toolbox that use the ROS, robotics operating system, to communicate among the various pieces. Okay, but the problem is that you can't do all these things separately. You can do your control, then give it to someone, and then get some sense algorithm from someone and add all things together. It's very difficult to do this. So you need something to start from your idea, have your requirements, do the application, implement somewhere in some piece of hardware, and then finally have the system working. You should do this in an integrated environment. Matlab is one of these, maybe the only one, where you can do all these things together. Because these are big problems when you have requirements and you want to go to develop your system. You face this problem. How can I trace requirements? How can I debug and design algorithm? How can I test design? As well as to go toward the implementation. How can I test the implementation? How can I translate to C or use Python or other languages? How can I verify and validate how much effective is the implementation compared to my algorithm? So all these tasks are very difficult, but in any industry environment, this is daily work. My recommendation for mainly the students is to try to manage and understand all these steps here. Because even if for your degree thesis is not important, this one, for example, but you want to go directly to the prototype and see if it's working, for the industry where you are going to work in the future, this is key. Why? Because this comes from the customer, and the customer is asking you, you have to produce something that does this. How can you say that this is effectively implemented in your device? So this is key. Okay, so what you can do here is that. Use Matlab to design and simulate. Simulate and simulate. Simulation is key because before you go to the first prototype, the prototype is expensive, take lots of time. You want to be sure that what you are doing in the simulation environment is working. And then you can perform system-level simulation. You can leverage built-in algorithms and apps available with Matlab and Simulink. You can even co-simulate with other simulators. For robotics application, there are environmental simulator like Gazebo, which is a 3D environment where you can make these virtual robots moving. And this is key because you don't want to go every time in some space like this and do the test. You want to do it in virtual environment first. And then when you go to prototyping and the implementation, you want to automatically generate C code. You want to perform seal or even processing the loop test. And in the end of the game, when you arrive here, what you got is something which is independent of the hardware you decide to use. This is key. So you are not linked to any specific hardware so far. Of course, once you decide the hardware that you want to use, you can optimize, of course. But in the future, if you decide to use another hardware, all you did before is okay. And this is key in the industry because the industry don't want to pay you again to do the same job twice. Okay. Okay. So let's go to the computer vision part of the topic, which is the one that allows you to perceive and understand how the surrounding is acting. And computer vision, basically, just to give you an idea, is something that extends the image processing capabilities toward detection, classification, and identification of objects and events. And these are the classical things that you can do with computer vision. So counting cars in a street. Many years ago, there was a guy counting like this, ta 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 ta, turning crazy after a couple of days. Then you can also do something like this, stitching. Is this important? If you are a photographer like me, as Obi, yes. But if you are working for, let me say, identification and planning of routes, then this can be key because you want to understand how all the information stitched together. Okay? And, well, tracking of object. This is a face, maybe you don't see very well, but I'm tracking a face here. So tracking object. What can be used for an example like that? Tracking object in the industry. Can you give me 2 examples? Why is this important? What can you track in the industry? When you graduate from university, you go to some company and they ask you, we need to track what? This is so important. Why? No clue? Okay, yeah?
Pedestrian next to the road.
Sorry?
Pedestrian next to the road.
Yeah, you need to track it. Come on. Come on. Yeah, this is important. Why? Because if you know where the pedestrian hits, that autonomous car is not going to hit. You save a life.
Yes.
That's key. Another example, rocket. The rocket should go somewhere, should track something. You have to track this object. Could be an information coming from infrared sensor, for example, and so on. Okay, there are lots of examples we can use. Shopping application. This is wonderful for the girls when they see, oh really, yeah. You know where is that used, for example? Amazon. Just an example, okay? When you put something in Amazon as a vendor, and you are going to sell, let me say, a bottle of water, you don't have to say, this is a bottle of water, this is a blah, 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 this is all the documentation, all the information. You just take a picture, send it to the market in Amazon, Amazon will detect it, this is a bottle of water. Okay. That's it. That's easy. Then, gesture recognition, which is basically the concept of object classification. You want to classify object. Can be for autonomous driving, can be also for in the industry. Can you imagine an industry where they create and build together mechanical parts automatically? The system should be able to detect the different pieces in a messy bag of many objects. It should be able to detect the object, classify, this is the screw, okay, goes here. This is not the screw, this is a round or whatever. This is a T-shaped tube, and so on. This can be also used in a situation like this. Okay, well, actually, this is an example. I have all these examples here, but since the time is not that much, I'm not going to show you. But you can easily find this example in the internet if you look for face detection and tracking using common filter, you will find it very easily. And since you have access to the tool, you have no excuses. So just go and find it, okay? So let's talk a little bit about detection and recognition. What's the difference? Can someone tell me what's the difference of detection and recognition? Give me one example. Come on. This one is going to get the biggest one.
Recognition is more comprehensive than detection. So detection has to detect there's
You're not convincing me.
Maybe I detect you, but
Yeah, you already got something. Someone from here. So one is the base of the other. So detection is the base of recognition. But recognition does also something more, which is
analysis.
sorry?
Analysis.
Okay, I will keep it. Sorry guys. Classification. So in the example that we saw before, let me go here. Oh, come on. Okay. This is a detection. I detected a face. I don't know the name of the guy. If I take the webcam and move here, I will do the same with all the faces here. But for the algorithm, one face is the same as the other. So they are all the same. There's a face. If you want to do classification, you can perform a classification and say, this is Larios, this is Attila, this is Peter, this is blah, blah, blah. So it's a higher level algorithm. How can we do, the detection is more or less easy. Classification is a little bit difficult. Because we need two pieces together. First, we need to have something like feature extraction. So, in order to do classification, we have to somehow create an information, extract information from the picture that represent the characteristic of this kind of images. Okay? One classical way to do this is using hog. Is someone aware of what hog means? Hog. Histograms of gradients. Come on, guys. It's very easy. It's basically if you take a picture of something and you translate the intensity of the image for each pixel like the height of a shape, the hog will give you the vector of the direction of the curve. Okay, basically, this is more or less the concept. So I will keep this one as well. My kid will be happy because he can play with these things. So, what kind of feature extraction can we use? We have lots. Here are just some of these, just few of them. First, the picture itself, it contains all the information, so but this is trivial. Okay? Then we have hog, so we have these small vectors telling me that the picture is going this direction rather than this direction. So it's not color based, it's more intensity based. Okay? Then we have other, I'm not going to explain you what stuff is, but then we have also bag of words. Basically, this is something like, it comes from the word classification. When you have a text and you want to classify a text, you look for let me say, the distribution of certain words. If the text has lots of words about Germany, probably this is an history book or geographic book or a touristic book about Germany, I guess. Okay? You can do this the same with images. So you can say the most important pieces of the image that conform this bike, of course, or bikes, are made like this. This is very important because you can detect the bike even if you see only one wheel. Even if this is hidden by a wall, for example. Okay, so, and then the second piece is machine learning. So, what is machine learning? So far we saw that we have lots of pictures, we can extract somehow the features. Then we need this piece here. So a model that helped me to do this, so to classify the images. So that once we get an input image, which can be a webcam pointing to a face of someone, it tells me, doing the same procedure of feature extraction, that this is Laios or Attila and not someone I don't know. Okay? This is called training, this is called classification. And it happens that the feature extraction that we saw before, there are various, you see there are many. And these are the machine learning techniques that you can use. Very likely, these are the classical combination, so you can use feature extraction with this kind of feature extraction and supported vector machine for machine learning. You can use also this one combination. A very common one is also histogram of oriented gradients with neural networks or with SPM. It's very common. Many customers use this combination. But in the last years, you can also do deep learning. Do you know what deep learning is? Science. So deep learning is this one. So deep learning is a different approach. It's not machine learning per se. It's neural network, but it's specific to images. The important thing is that we provided, starting with 16A, this capability. Why? Because it happened that 2 or 3 years before, an international competition demonstrated that deep learning techniques have a better accuracy than humans. 1 year before it was not like that. Humans were better recognizing objects, but you can't imagine deep learning can do a better job than humans. It's incredible. I can understand when you see colors because I can recognize 7 or 8 colors. My wife can recognize 29 or something like that. I think that deep learning is able to recognize 50. But in the last release, we also upgraded this capability. Well, since you don't know deep learning, maybe this can look odd. What's this? But basically, you can leverage available already models already available in the internet. AlexNet is one of these that allows you to do this kind of things. If you have, since you have access to the 17A, you can take this example, just run some code, and you have it. You can immediately see this. There's one problem, well, 2 problems. The first is that if you use a pre-trained model, it's okay. If you don't have a model and you want to train a model with deep learning, you need a GPU. Why do you need a GPU? Because in order to train a model like this, with a GPU, it can take 3-4 days, continuous computation. If you don't have, don't even try, because you can't, because our tool doesn't allow this. Okay, so other things that you can do with computer vision. Stereo camera calibration. Why is this so important? Stereo camera calibration. Because many industrial applications use camera, webcams, basically, in a stereo configuration. With this configuration, you are able to do, for example, depth estimation, and you can even reconstruct the 3D scene around. Why is this so important? Because they are cheap. Cameras are cheap. The alternative to do something similar would be using a LiDAR sensor, which are very expensive. Okay. Let me check the time. Okay, then you can also do this kind of thing. It's nothing new. It's 14A. You can do text recognition. There are plenty of examples of these kind of things. If you don't worry about this, well, you should know that you can do also in Japanese, just in case. Okay. Then you can do also nice things like 3D point cloud computing. So 3D point is very important because it's something that you get from stereo cameras that you calibrated before, for example. This is an example of a robot moving inside Matlab's offices with a Kinect camera. Kinect is a binocular camera. It has also a small sensors over there. And you can get this information. You can reconstruct all the scene. And these are all points, 3D points. The more thing that you can do with the latest release, well, this is 15B, so it's some time ago. You can also perform geometric shape fitting. So if you want to recognize planes or cylinders or spheres, you can do this automatically. Very important. Okay. And then here it comes. One of the most important things is that generally Matlab is open to other tools. This is just an example. It's not the only one. So you can use OpenCV libraries inside Matlab, just using this OpenCV interface. But generally, you can use any piece of C code inside Matlab. you can call Matlab engine, so performing computation in Matlab from your C language. So if you have an application in C and you want to leverage the power of Matlab, you can do that. Okay. You can do the same thing with Java and with Python. So you can call Matlab from Python and Python from Matlab. So you can collaborate with these languages in a very effective way. So, one question. Do you use any open source software? I guess, yeah. For example, which one?
I'm working on Ubuntu, so generally LibreOffice these are the open source.
Okay. Any other? So I guess you use Python. Many people use Python. It's with the language. I love it. You can use it with Matlab. You can call Matlab from Python. C language per se is open. I mean, it's there. You can use it. You can call Matlab from C and call C language from Matlab. Okay. Let's see the time. Okay. So let's quickly see now something about the robotic system toolbox, which is one of the pieces that we saw before when we were talking about autonomous design of something. Okay. One of the pieces was perception, and that was covered by computer vision, really. And the other one was routing, planning, communication, and this is covered by robotic system toolbox. This is a new toolbox come out in 15A, so 2 years ago. What you can do with robotic system toolbox? Well, you can do a couple of things, more than two maybe. One of the things which is very important is that you can interface Matlab and Simonic to ROS. Is someone using ROS? Okay. Someone answer? Okay. A couple of ones. Good. So ROS stands for Robotic Operating System, but it turns out that it's not an operating system per se. But other than this, and other than the fact that you can generate standalone nodes from Matlab and Simonic, that you can deploy in some devices, you can also use algorithms ready to go, ready. They are there, just use them. You don't have to prepare or create any path planning or localization or QPC grid. They are already available on the robotic system toolbox. Just take them, use them. Okay? If you are not happy with them, sorry, you can develop your own and let us know. Okay? And then this is more specific for manipulators. There are some capabilities about the design of manipulators, so rigid body, inverse kinematics. I mainly work with this kind of things. I have another colleague that works with these kind of things. In the presentation, I have some slides about these topics. I will let that in the presentation. You will get access to the PDF file, so you can have some insight about that. Okay, but I rarely will talk about this. So these are some applications. So this is the one that we saw before, is creating the map of the scenario. This is recognition and planning. You see there is a limit, it can recognize stuff. This is a manipulator application. This is a sort of, can we call a small ADAS system, autonomous driving system. Actually, it's a robot with wheels, has sensing and has planning, so it can move alone independently without eating, without doing messy things around. Okay. So this is ROS. ROS is used. Well, the story of ROS is quite interesting. Many years ago, it was mainly and only used at the university and research centers. That was very nice. At a certain point, the ROS environment come out from the university and research center, and now it's used also in some industries. We will see a slide where there is a list of companies that are using ROS for their application. You can be amazed at how many companies are using it. So what you can do is something like that. You are able to write your Matlab code. You can leverage the built-in algorithms inside the robotics system toolbox. You can have also the need to perform some modeling. And then you have all these things about robots, models of robots already available, environmental, simulator. This is gazebo if I can recognize. And using the ROS networking, you can connect all these pieces together. So one of the things that we had in, I think, the last year is that you can also use ROS with Raspberry Pi 3. Number 3, the third edition that came out last year. You can generate ROS node for that device. That's amazing because it's very cheap, it's very affordable, and it's very nice. Okay. The gazebo simulator, does someone know what the gazebo simulator is? Have you ever used a simulator like this one? Okay. Yeah, basically it's a simulator of the 3D environment where you can simulate obstacle and everything. You can also simulate actors like robots. So there are already some models already available. Turtlebot is one of the one that I really enjoy. Is this guy here? Is a small robot like this. He has some wheels to move and a Kinect too, if I remember, that you use to recognize environment, and a small PC on top of it. And you can use this model inside the gazebo and make it act like a real one. So before going on the field, you can simulate everything here, which is much better because you don't break your turtlebot because it's falling down the stairs or something like that, for example. Okay. So yeah, these are more detailed list of things that you can do with ROS, messaging, the kind of services. But if you don't know much about ROS, but you have a colleague here that you can ask out. So I will skip this one. And this is the slide that I wanted to show you. So who is using ROS today? So ROS is used, of course, in many universities, but in lots of industry around the world. ABB, Caterpillar, Boeing, BMW, John Deere. I know many of the automotive ones because they are the one that I work with quite often. Siemens, then Perry, Rensselaer, which is the University Research Center, and so on. And this is an old slide, so I think in the meantime, there's 2 years there are more using it. Okay, this is an example of ROS connectivity. Unfortunately, you can't see the code here, but nothing really extraordinary. The robotic system toolbox is full of examples that you can take, hit the button, run, and work. So no problem about this. Basically, you see here the gazebo simulator and the same application in the real world. Have to handle this blue wall over there. Okay. Unfortunately, the resolution is very bad. Okay, so we saw lots of nice things over there, many videos. We mainly talked about Matlab because when we talk about image processing, computer vision, we are mainly talking about Matlab workflow. But there is another workflow which is based on Simulink. Who is using Simulink today? Of course, you are using everything. So, come on, right? You deserve it. So, who else is using Simulink? Not so many people using Simulink? Do you know what Simulink is? Of course, oh, come on. that's good because many people have no idea what Simulink is because they use other things or they are more Matlab oriented. Okay, Simulink, just to synthesize this, the meaning of Simulink. Simulink is a graphical environment where you can model and simulate dynamic systems. This says everything and nothing, but this is the truth. Okay, Simulink is very good when you want to add the concept of time to your algorithm, because time is something embedded in Simulink. While Matlab, when you write a Matlab code, where is time? You have to add this concept to your code. In Simulink, the time is already there. Okay? And it's very good when you have to connect to the hardware. So if you want to connect to the hardware and you want to generate code from your algorithm and deploy this algorithm into your hardware, Simulink is the preferred path. You can do also with Matlab like this. I will strongly recommend you to use Simulink. And this is the key, why to use Simulink. Because what you do in the simulation, 95% of the time, is what you get in the final deployment of the algorithm. So simulate as long as you can. Perform all the tests that you need. Every time that you do some upgrade to your model, to your project, you will have tests to verify that this is working correctly. Once you pass all the tests, maybe you are ready to go in deployment stage with some hardware. Okay. These are some examples. We already saw this one. These are more specific about planning. I will go very quickly. This is obstacle avoidance algorithm that is available in the Robotics System Toolbox. This is shipped in ThinkB, so you have access to it. These are some examples about autonomous ground vehicle algorithms, so SLAM algorithm, search, organization, and mapping. This one was the first one, so he is able to build all the map. Is able to locate, not to build a map, to locate. If you have a map and you say this is the map, the robot is able to locate himself. But that was in 16A. Then in 16B we had an environmental mapping, so you don't tell the map, you say nothing to the robot. You say, you are somewhere, can you give me the map of the area? I will give it the map of the area. Just let him work, and sooner or later you will get all the map of the area. And okay, this is future release, but this means 17A. You can also do the same thing, but also with matching capabilities. Because you see that it's adjusting itself, because it's call pointing, so you have to somehow match what is funding. Can you imagine where this kind of application are key in the industry, outside the university? Just a couple, just two. One is obvious, autonomous driving, for example. The other one of the most important things is that there is a big focus in the academia research center, and as well in some industries, about those autonomous robot applications that have to interact with situations where humans can go. There is a problem in a nuclear reactor. No one will go there, absolutely. You can do this with some remote control robots, but if you can't because of some reason, you need an autonomous system. The robot will automatically go there, verify all the system, verify that this is the valve to close. It will handle the valve or will switch it off automatically alone. This is one of the key points. Another example of this kind of application is when you have a robot that needs to to go in the middle of a fire, where the temperature is very high. No one can get in. But yes, the robot maybe for a couple of hours can get in. After 2 hours is dead as well. Or in a situation where there is lots of earthquakes. Italy is one of these. Italy has lots of earthquakes. Chile as well, other places like Greece. Can you imagine a situation where a robot, even a small one, can autonomously go inside a situation where no one can get in because it's too risky? Okay. Submarine also. No one can go 2 kilometers down the sea level. But autonomous robot can take decision about this. So the American Navy lost one bomb. We have to rescue, we have to find it autonomously and take it. Okay, we can do that, maybe. Okay, there are lots of examples like this. Okay, there are other examples of localization. Monte Carlo is one of these. Then in the 16B, so 6 months ago, we also had the accuracy grid. So that automatically the robot can understand where it's not possible to go because of some accuracy. Turtleboard support, this is the turtleboard I was mentioning before. This is the Kinect. This is the PC that owns the intelligence. This is the system with wheels. It's so big, it's not that much.
We have this robot in our factory.
Do you have it?
Yes.
Is it nice?
Yeah.
That's wonderful. Did you ever use it to bring pizza to your colleagues? There is a pizza day or something like that. You buy the pizza, you say the colleague where is it, he automatically avoid everything and reach the colleague and this is the pizza. It's cold, I'm sorry. It takes me 1 hour to reach it. These are an example. This is the German Aerospace Center. It developed this robot with manipulators able to take even eggs, small eggs, without breaking, can manipulate very carefully everything, can take and place, can do lots of things. This is another example of the meat in Boston. This is exactly one of these situations where there is something hot coming here, toxic gases or fire, and you want to close a valve, for example. This is exactly what is doing here. Okay. So there are, around the world, there are lots of challenges that university can take part to develop these kind of things. So these are, of course, no challenges. This one comes from a challenge, actually. So if you want to develop this kind of application, I will strongly recommend you to take part in these challenges worldwide. And if you do with Matlab's tool, well, you don't have excuses because you have access to the tools. But if you want really to do something higher level, you need, you think that maybe you can't afford everything, and you need extra help from Matlab, just reach out to us. Maybe we can give you that extra help to provide you with this example of challenging situations. So manipulators, as I mentioned before, this is not really my field, but if you are happy to see these things, there are lots of examples about the kinematics, inverse kinematics in the toolbox. For me, this is something a little bit boring, because this is not my method. Okay, I'm going to show you some videos because you can perform also in the interactive way the inverse kinematics. And then, here we are. Okay, last 25 minutes. One of the most important applications about autonomous system is, okay, you say autonomous driving, which is not really ADAS. So ADAS originally was advanced driving assistance system. Now is going to be automatic driving assistance systems. Now is going to be autonomous driving advanced services. Someone call it different ways. As you wish. Okay. But we will always refer to this like automatic driving, AD. So this is a standard called SAA J2016, which classify the kind of autonomous level for the cars. So zero is